Can a global radio network detect MH370 even when radar could not? Welcome to Independent Aircraft Investigations. My name is Richard Godfrey. Today we are going to investigate whether, buried in weak signal propagation data, there may be traces of an aircraft that officially vanished. In this investigation, I'm going to discuss whether WSPR data can actually track MH370 and whether previous claims hold up under technical scrutiny. This work is dedicated to the families and friends of those lost in this tragic incident. The Indian Ocean is a large place, around 27 million square miles, or 70 million square kilometers. Somewhere out there, an aircraft disappeared. Malaysia Airlines flight MH370 departed Kuala Lumpur and proceeded normally along its planned route. And shortly after the final radio transmission, the aircraft deviated from its airway and was last observed on military radar near Penang. Beyond this point, there are no conventional tracking data. What follows is not a reconstructed path, but a sequence of detections derived from WSPR signal disturbances over time. Each point represents a moment where radio propagation was measurably affected, consistent with the possible presence of an object moving through the atmosphere. Presented here in its raw form, prior to statistical filtering or interpretation. We have filtered out only the large anomalies greater than 2 standard deviations from the mean over a multi-hour time window. When viewed again, the same data begins to reveal structure. The apparent randomness reduces, and a continuous southward progression emerges. Not a precise navigation track, but a coherent movement through space and time. Together, these detections suggest a probable flight path. Extending from the final radar position into the southern Indian Ocean, across the wider detection network, multiple signal interactions were recorded. Individually uncertain, but collectively informative. Applying statistical filtering, a subset of the most significant anomalies remains. These are not evenly distributed. They cluster. Where multiple indicators intersect, a region of highest probability emerges. Consistent with the final phase of flight and the expected end of flight dynamics. This is not a single piece of evidence, but a pattern of convergence. WSPR is not yet widely validated for aircraft tracking. This method remains experimental and is not yet established as a standard aircraft tracking technique. This case study examines the use of radio wave data from the WSPR Signal Propagation Reporter, WSPR network, and its historical database called WSPRnet. It proposes that whisper perturbations in transmission paths can be associated with the presence of an aircraft along or near a great circle propagation path. This work should be understood as a testable hypothesis rather than a confirmed conclusion. While the results show alignment with multiple lines of analysis, definitive validation requires physical evidence from the seabed, and the hypothesis remains subject to falsification through further data or search outcomes. Signal level and frequency variations may occur when an aircraft intersects or perturbs a whisper propagation path. These variations can be considered alongside Boeing aircraft performance modeling, Malaysia Airlines operational data, meteorological conditions, Inmarsat satellite data, and drift analysis. Together, these sources allow a coherent reconstruction of the final hours of flight for MH370. The objective of detecting and tracking MH370 across the Indian Ocean is to assess the reliability of the reconstructed flight path during the approximately 7 hours and 46 minutes of flight after loss of contact, and consequently the estimated endpoint location following fuel exhaustion and descent. The alignment between Boeing performance analyses, Inmarsat data, and drift modeling from the University of Western Australia represents a notable multidisciplinary consistency, with all approaches constraining the crash location to a similar region along the seventh arc. The whisper-derived flight path is consistent with these constraints. However, this does not constitute a fully independent multidisciplinary convergence, as these methods are ultimately constrained by the geometry of the Inmarsat seventh arc, with different approaches fitting within that shared framework. Data recovered from Captain Sahari Shah's home flight simulator indicates a flight path that intersects the seventh arc at approximately 29.1748 degrees south, 98.9251 degrees east. This position lies approximately 33 nautical miles from the corresponding whisper-derived crossing point, representing a broadly consistent, though not exact, alignment. Accordingly, the hypothesis defines a specific geographically constrained search area that can be directly tested through targeted seabed exploration. The last known position of MH370, based on the Butterworth primary civilian radar, was 5.589 degrees north, 99.165 degrees east at 1801 UTC. The regional radar data contains 1,394 regular estimates of latitude and longitude at approximately 3-second intervals from 1641 UTC to 1801 UTC from 4 different radar stations with 2 small gaps. A single additional latitude and longitude position was reported at 1822.12 UTC, but this was discounted due to the large gap to the penultimate radar position. and possible inaccuracy due to the long range. From this point at 1801 UTC onwards, there are 67 positions comprising a total of 125 anomalous whisper links, which intersect with the MH370 flight path at the estimated position of MH370. Let's have a look at the method that we used in this paper. In the time frame of interest for the MH370 flight path analysis between the 7th of March 2014 at 1640 UTC and the 8th of March 2014 at 0100 UTC. There were 250 whisper data sets every 2 minutes. In total, we examined 75,822 whisper links globally, between 10,000 and 799 distinct transmitter-receiver pairs. There were 2,401 whisper links crossing the target area around the MH370 estimated position each 2 minutes. The ground speed and track of MH370 are calculated every 2 minutes. The true airspeed and heading are also calculated, given the wind speed and direction for that position and altitude and time. The max setting was also calculated from the true airspeed and the static outside air temperature. The wind and the air temperature data are derived from the NOAA GDAS historic database and interpolated over a grid with 1 degree of latitude by 1 degree of longitude in position and 5 pressure altitude levels between 350 HPA, nominally 26,631 feet, and 150 HPA, nominally 44,645 feet. The fuel consumption in each engine is calculated each minute from the actual aircraft weight, the delta static outside air temperature, the max setting, and the mass engineering data for the 2 engines installed on 9M MRO. The MH370 estimated position was updated every 2 minutes to align with the whisper data. A total of 987 whisper links were analyzed that crossed within a radius of the MH370 estimated position, defined by the distance covered from the last known position at maximum possible ground speed. The master antenna locations database and the MATLAB software scripts are included in our paper. A plausibility check is performed on the anomalous whisper links using the PropLab Pro version 3.2 software. The propagation path between transmitter and aircraft, as well as aircraft and receiver, is analyzed using the International Reference Ionosphere, IRI, 2007 model, as well as a topographic model of the Earth. The transmission frequency is checked to be within the maximum usable frequency, the MUF, and a multi-hop ionospheric path is confirmed at an elevation angle EA to be within the specified range. The EA is sometimes called the takeoff angle. We make a search recommendation based on the convergence of the whisper-derived tracking, Inmarsat satellite constraints, aircraft performance modeling, and the oceanographic drift analysis, future search efforts may consider prioritizing a geographically constrained area along the seventh arc centered on the whisper-indicated end-of-flight region. This area lies within the broader latitude band of approximately 28 degrees south to 33 degrees south, identified by drift studies from the University of Western Australia. But it is further refined by the reconstructed flight path and terminal dynamics. Earlier seedbed searches did not comprehensively cover all areas beyond the immediate vicinity of the arc, particularly in regions where complex terrain may have limited detection capability. Targeted examination of these zones using high-resolution bathymetry and autonomous underwater vehicles may therefore be warranted. The hypothesis presented here defines a specific and testable search area, and its validity ultimately depends on whether wreckage is located within this region. At this point, the question is no longer whether MH370 can be modeled. The question is rather whether the correct area has been searched. Let's have a look at the WSPR data. MH370 passed Penang Airport at around 1752 UTC. MH370 was still being tracked by military and civilian primary radar, although it had gone dark. The co-pilot's mobile phone was detected by the BB Farlim 2 base station at Bandar Baru Air Itam on Penang Island at 17:52:27 UTC. From that point onwards, there were 67 positions which this case study presents. And for each of these 67 positions, a map with the estimated MH370 flight path up until that point is presented. The 3D propagation path of the whisper signal interacting with the aircraft at altitude is shown in a worked example. For each of the 125 anomalous whisper links between each transmitter and receiver, the propagation data over a 3-hour period before and after the time point with the mean, standard deviation, and actual deviation is calculated and presented. In conclusion, if this hypothesis is correct, then the aircraft is not lost. MH370 is simply waiting to be found in a location that we have not yet searched. Independent aircraft investigations brings you the established facts. We provide traceability of all evidence to a source authority. We make a clear distinction between factual data and analytical interpretation. Aviation news is covered on daily airline news as it happens. This channel is reserved exclusively for in-depth investigations. If you find this analysis useful and want to see future independent investigations, then subscribing to the channel helps ensure this work continues. Thank you very much for watching and have a good day.